A powerful 7.6 magnitude earthquake shook Japan, injuring at least 30 people and damaging buildings and infrastructure.
On April 20th, 2026, residents across northeastern Japan felt the ground move beneath their feet. A magnitude 7.7 earthquake had just torn open the sea floor, about 100 kilometers northwest of Japan's coast. Within minutes, tsunami waves began striking Japan's northeastern coast. Sirens started blasting around the coastal communities, and thousands of residents rushed toward higher ground as authorities warned that waves of up to 3 meters could follow. But just as the threat seemed to be growing, it started to fade. The warnings were downgraded. The sirens went quiet. And by 11:50 that night, it looked like the worst was over. However, as things began to return to normal, Japan's Meteorological Agency did something nobody expected. It issued another warning, a megaquake advisory covering 182 cities and towns from Hokkaido all the way to the edge of Tokyo. So why would an agency issue its most serious warning after the shaking had already stopped? To understand this, let's understand what happened in the earthquake in the first place. The earthquake, April 20th, 2026. At 4:53 p.m., just 100 kilometers off the coast of Iwate Prefecture, the seafloor cracked open. The rupture began 35 kilometers beneath the ocean floor. It lasted 12 seconds, and in those 12 seconds, a section of fault that seismologists had been watching for years released everything it had been quietly storing. The first reading from the United States Geological Survey put the magnitude at 7.4, a significant number on its own. A 7.4 earthquake is capable of widespread destruction, capable of generating a deadly tsunami, capable of killing people. But within minutes, Japan's Meteorological Agency, which runs a denser, more sophisticated network of seismic instruments positioned directly above this fault, came back with a different number. 7.7. Now, if you're not a seismologist, that might sound like a minor correction, but it is not. Earthquake magnitudes run on a logarithmic scale, meaning every full point upward represents roughly 32 times more energy released. The jump from 7.4 to 7.7 alone represents nearly 3 times the energy. That is not a rounding error. That is a fundamentally different earthquake. Almost immediately, tsunami sirens fired across the Sanriku coastline. Emergency loudspeakers activated in coastal towns. Miyako Port recorded 40 centimeters. The tsunami was much smaller than expected, and by 11:50 p.m. that night, the warning was downgraded and eventually lifted entirely. The final damage report showed 10 injured, around 40 buildings damaged, and no deaths. On paper, it could have been catastrophic, but it wasn't. However, what happened next worried scientists even more than the tsunami. Shortly after the shaking stopped, Japan's Meteorological Agency issued a rare megaquake advisory. This was not a warning that a giant earthquake was about to happen. Instead, it was a warning that the risk of another much larger earthquake had increased. The advisory covered 182 municipalities along Japan's Pacific coast, from Hokkaido in the north to Chiba Prefecture near Tokyo. Officials explained that under normal conditions, the chance of a magnitude 8 or larger earthquake occurring within the next 7 days was about 0.1%. After the April 20th earthquake, that risk increased to approximately 1%. That may still sound small, but to seismologists, it represented a tenfold increase in the likelihood of a potentially catastrophic earthquake. But how could an earthquake that caused relatively little damage trigger a warning that stretched across much of the country? To understand this, we need to look at what was already happening beneath this coastline long before the earthquake began. The warning signs. Between November 2025 and April 20th, 2026, seismologists recorded 162 earthquakes of magnitude 4.0 or higher in the same offshore region where the magnitude 7.7 would eventually strike. 5 of those earthquakes were larger than magnitude 6.0. The strongest occurred on November 9th, 2025. It measured magnitude 6.8 and was powerful enough to trigger a tsunami advisory for Iwate Prefecture. Then, on March 27th, just over 3 weeks before the main earthquake, another magnitude 6.5 struck almost the exact same area of the Japan Trench. At the time, it was recorded and studied, but attracted little public attention. Looking back, the pattern is hard to ignore. In just 5 months, more than 160 significant earthquakes shook the same section of fault. The activity continued to build in the weeks leading up to April 20th. And in hindsight, it looks less like a series of separate earthquakes and more like a warning that something bigger was coming. But what was causing all of this activity? You can think of it like a rusty drawer. At first, it refuses to move. Pressure builds. Then, suddenly, it jerks forward. Earthquakes happen in much the same way. And in the area where the April 20th earthquake occurred, the geology makes the process even more dangerous. The fault becomes steeper, increasing from about 5 degrees to roughly 15 degrees. That may sound like a small change. Underground, it is not. Changes in a fault's shape can concentrate stress into specific areas. Those areas can store more strain and are often more likely to produce large earthquakes. In other words, this was not just a fault under pressure. By the time the magnitude 7.7 earthquake struck on April 20th, there was one more specific reason that JMA triggered such an unusual response. This stretch of coastline carries a memory that Japan has never forgotten. The shadow of 2011. March 11th, 2011, at 2:46 p.m. One of the most powerful earthquakes ever recorded struck off the coast of northeastern Japan. The earthquake measured magnitude 9.0. It occurred along the Japan Trench, the same fault system involved in the April 2026 earthquake. The rupture stretched for about 500 kilometers and lasted more than 3 minutes. In some places, the seafloor moved by as much as 50 meters. Huge sections of the ocean floor were suddenly lifted upward. It crossed the Pacific Ocean and was detected in countries all around the ocean basin. Along Japan's coast alone, more than 560 square kilometers of land were flooded. When the disaster was over, the scale of the destruction became clear. More than 15,900 people were killed. Another 2,500 people disappeared and were never found. More than 1.2 million buildings were damaged or destroyed. Entire communities vanished in a matter of minutes. Then came the after effects. The tsunami flooded the Fukushima Daiichi nuclear power plant. Its critical cooling systems failed, and 3 nuclear reactors melted down. For years afterward, Fukushima became a symbol of how a natural disaster could trigger a technological catastrophe. The total cost of the disaster exceeded $360 billion, making it one of the most expensive natural disasters in history. The earthquake changed Japan forever, and over the next 15 years, the country invested billions of dollars to prepare for the next major disaster. The network includes around 150 observatories connected by thousands of kilometers of cable across the Pacific Sea floor. Its job is simple: detect earthquakes and tsunamis as close to their source as possible and provide precious extra minutes of warning. And when the magnitude 7.7 earthquake struck on April 20th, 2026, The system did exactly what it was designed to do. The sensors detected the rupture. The warnings went out. Coastal communities evacuated. The tsunami arrived smaller than feared, and lives were saved. And that brings us to the question everyone is asking. Why this region? Why does this particular stretch of the Japan Trench face some of the worst earthquakes regularly? The Sanriku Gap problem. After the 2011 disaster, scientists spent years studying exactly how the fault moved. They used GPS stations, satellites, seafloor sensors, and earthquake records to create detailed maps of the rupture. And what they found was surprising. The central part of the Japan Trench moved a huge amount during the 2011 earthquake. In some places, the seafloor shifted by more than 50 meters, but the northern part of the trench did not move as much. This area, offshore Iwate and southern Aomori, was less affected than the regions to the south. The April 20th, 2026 earthquake happened at about 39.95 degrees north latitude. That is right inside this northern section. Now, the timing matters. The Pacific Plate is still moving beneath Japan at about 8 to 9 centimeters per year. Over 15 years since 2011, that adds up to around 1 to 1.4 meters of movement. So pressure has been slowly building again in this area. Some scientists think this section may have also already carried leftover stress from before 2011. A simple way to imagine this is a spring. If you only release part of a spring and then keep compressing it, the pressure builds up again over time. This is what makes the Sanriku Gap important. It is a section of the fault that has a history of incomplete stress release and complex earthquake behavior. The April 20th earthquake released some of that built-up energy. It broke a zone about 70 by 65 kilometers wide, with up to 4.7 meters of slip near the center. That is still a strong earthquake, but the whole northern trench system is much larger than that area, and the rest of the fault is still active. Stress is still building where the fault did not fully break in 2011 or 2026. That is why scientists are not calling this an ending. To them, it looks more like one part of a much longer process. The part that didn't move. In early 2026, scientists from the University of Tokyo studied long-term data from the Japan Trench, and they found that the fault is not the same everywhere. Some parts of the plate boundary slowly release energy through small earthquakes and gradual movement, but other parts are completely locked. In these locked zones, almost no energy is released. Instead, stress builds up year after year. These are the areas scientists worry about most. You can think of these areas as sections of the fault that are saving everything up for later. And those are exactly the kinds of places that concern earthquake scientists the most. Then came another study in January 2026 that focused on a different piece of the puzzle. Researchers confirmed what many geologists had suspected since the aftermath of the 2011 Tohoku disaster. That may sound like a technical detail, but it had enormous consequences. Because the rupture reached the surface, parts of the seafloor were displaced by extraordinary amounts. In some locations, movement exceeded 50 meters. That sudden uplift of the ocean floor displaced massive volumes of water and helped generate the devastating tsunami that followed. What makes this finding particularly important is that those similar clay-rich layers still exist along much of the Japan Trench. In other words, one of the key ingredients that contributed to the 2011 tsunami is present across a much larger portion of the fault system. And that matters, because, according to the USGS finite fault model, the earthquake ruptured an area measuring roughly 70 kilometers by 65 kilometers. maximum slip reached approximately 4.7 meters. The entire rupture lasted about 12 seconds, with most of the energy being released in less than 10 seconds. Those numbers describe a major earthquake, but they also show that it was relatively confined. What happened on April 20th was the release of stress from a specific patch of the fault. While most of the Japan Trench did not move, the surrounding sections remained locked. And that leads us to the question everyone is asking. Was this just the beginning? See, here's the problem. After a large earthquake, there are two possibilities. One, it is the main earthquake. It releases built-up stress in the fault. After that, smaller aftershocks slowly decrease over time. Two, it is a foreshock. It is the first large break. It shifts stress onto nearby locked areas, and it can increase the chance of a much larger earthquake. The problem is simple. In real time, you cannot clearly tell which one it is. Only later does the pattern become clear. The April 20th, 2026 earthquake had a long buildup. There were 162 earthquakes of magnitude 4.0 or higher from November 2025 to April 20th, 2026. This sequence is now known as foreshock activity, but before April 20th, it was not clear. It could have been just a normal earthquake swarm. After the main shock, scientists began watching the aftershocks closely. By April 23rd, there were 17 aftershocks above magnitude 4.0. The strongest reached magnitude 5.6. Now, they are comparing this pattern to a known rule called the Omori-Utsu law. This law says aftershocks should slowly decrease in number and strength over time. If the aftershocks decrease normally, it suggests the April 20th earthquake was the main event. If the activity stays the same or increases, it could mean stress is still moving through the fault. Scientists are also watching the ground itself. GPS stations across the Tohoku region are measuring how the land is still moving after the quake. This is called afterslip. Normally, afterslip happens on deeper parts of the fault and slowly fades over weeks. If the pattern is unusual, it could mean stress is being pushed into nearby locked sections. Ocean bottom sensors are also checking for changes in pressure on the seafloor. These can show if the ground is still deforming underwater. The honest truth is this: seismology cannot yet say in real time if an earthquake is the main event or just the start of a bigger one. That can only be understood later. We can see a similar pattern in the past. In 869 AD, a massive earthquake struck this same coast, reconstructed now as a magnitude 8.9 event, generating a tsunami that flooded the Sendai Plain for kilometers inland. That event was preceded by years of elevated seismic activity in the same region. And then there is the number that nobody in northern Japan could stop thinking about on the evening of April 20th. On March 9th, 2011, a magnitude 7.3 earthquake struck the same area. 2 days later, on March 11th, 2011, a magnitude 9.0 earthquake followed. That is the number that stayed in people's minds, because everyone wants to know what happens next. The aftermath. At exactly 5 p.m. on April 27, 2026, the megaquake advisory officially expired. 7 days after it was issued, Japan's Meteorological Agency and the Cabinet Office lifted the warning for all 182 municipalities from Hokkaido in the north to Chiba in the south. A government official, Kota Iwamura, said clearly, "The lifting of the advisory doesn't mean that a major earthquake will no longer occur." That one line mattered. The advisory period was over. No magnitude 8 or larger earthquake had happened in those 7 days. More than 17 events above magnitude 4.0 by April 23rd, with the strongest at magnitude 5.6, were slowly decreasing. On the surface, everything looked like the normal outcome. But scientists are still worried, because lifting an advisory does not change what is happening deep underground. The Japan Meteorological Agency also made this clear. The risk did not go to zero. It dropped back down, but it still exists. And in this region, it always exists. Long-term studies show something important. Along the northern Sanriku coast, there is a 4% to 20% chance of a magnitude 8 or larger earthquake within the next 30 years. The last one in this area was in 1968. It was the Tokachi earthquake, magnitude 8.3. That was almost 60 years ago. Since then, the Pacific plate has kept moving. It moves about 8 to 9 centimeters every year. Over 60 years, that adds up to more than 5 meters of movement. That energy does not disappear. It builds up again. When a fault breaks, it does not always release all the stress. It can also move stress into nearby locked areas. That is what scientists are still studying. Then there is another concern. This is not the only major event in recent times. In December 2025, a magnitude 7.6 earthquake struck near Aomori, about 140 kilometers from the April 20th epicenter. That event triggered the first Hokkaido Sanriku advisory. Then April 20th triggered it again. 2 advisories in less than 5 months. That is rare. And it shows how active this fault system has been. So what happened in Japan on April 20th, 2026 may have been part of a much larger story, or it may have been the end of one. We simply don't know for sure. What we do know is this: the fault is still there. The plates are still moving, and stress is still building beneath the Pacific Ocean. Whether this earthquake was a warning, a release, or just another step in a process that has been unfolding for decades is something only time will reveal. Until then, stay safe, take care of the people you love, and never take the time you have together for granted. If you enjoyed this video, please give it a thumbs up and subscribe for more informative videos like this. We'll see you in the next one.